Good morning, children. Today we are going to see the subtopic, what happens when metals react with acids. Hope all of you have read yesterday's. No, I am very happy because yesterday some children they had a doubt that when metals react with water, I have given calcium reacts with hot water, right? In the first chapter, we have studied that in combination reaction, when quicklime is mixed with water, you will get slate lime. What is the formula for quicklime? CaO. No, calcium oxide. When it combines with water, you will get calcium hydroxide, and enormous heat will be produced by cell. Correct? Keeping that in mind, some have thought that how can it react with hot water, because the reaction will be vigorous, no? So what you said is correct. Calcium reacts with cold water. It reacts with cold water, but what happens, no? The reaction will not be very fast like that of sodium and potassium. It will be very slow. Okay, so with very hot water we are not checking. With warm water, if you check, the reaction will be little fast. But with cold water, the reaction will be slow. To avoid accidents, it is better to use which water? Cold water. Okay? Good. Now we will see what happens when metals react with acids. This is the third subtopic. Right? As usual, we will be studying the formula. What is the formula of metals? When it reacts with dilute acids. Keep it in mind, it is not concentrated acids, dilute acids. Metal plus dilute acids gives salt plus hydrogen. Okay, whichever salt we are getting now depends upon the metal. So metal plus dilute acid gives salt plus hydrogen. This is very important. Dilute acid, not concentrated acid. With the help of an activity, we will come to know how this reaction takes place. We have already studied the reactivity series. Now we have some idea how the reaction will take place. As it is dilute acids, the reaction same like that of how it happens in water. Here also the topmost metal will be more reactive. So is it possible for us to check with sodium and potassium? No, we will not use sodium and potassium, because even with water the reaction will be vigorous and heat will be produced by cell. That's the reason we are keeping inside kerosene. Which one? Sodium and potassium. So we will not use, for this activity, we will not use potassium and sodium. We are not using potassium and sodium. Okay. All the other metals you are taking. Now what will you do? How to check this? We will take some 5 test tubes. Okay. 5 test tubes we are taking. And we will put some dilute acid. It can be HCl or H2SO4. Keep it in mind, it's HCl or H2SO4. Dilute HCl, H2SO4. Anything we can take. And we are taking, filling it with half the test tube we are taking acids. Okay. And we are not using potassium and sodium. From the next metal, we will drop a small piece of that metal and we will see what is happening. I told you that it is an acid. Whichever acid we are using now, HCl or H2SO4, it's an acid. It is dilute acid, but it's an acid. So what will happen? Heat will be produced. To check the amount of heat produced, we can also put a thermometer in each test tube. In a thermometer, a bulb will be there. Okay, that bulb should touch the acid so that we can find out the amount of heat produced. Okay, like that we are keeping. We will keep this activity aside. We will come to know which metal reacts very fast, which metal is very slow. After, by the end of the experiment, you will come to know that magnesium reacts fast, then aluminium, then zinc, then iron, like that it goes on. See, seeing this now, it is interesting to know that metals which are placed above hydrogen, see, metals which are placed above hydrogen, where? In the reactivity series. We have studied the reactivity series, no? The metals which are placed above hydrogen in the reactivity series, they react with what? Dilute acids, both HCl or H2SO4, and you will get, see here, with metals which are placed above hydrogen reacts with the dilute HCl or dilute H2SO4 H2SO4, we are not using concentrated acids. You will get metal salt. Plus, what will be you get? Hydrogen. Okay, metal salt and you will get hydrogen. For example, see sodium. Sodium is a solid. Okay. HCl. Here we are not using sodium in the activity laser because it is but to know how it happens. We are just writing the equation. Sodium plus HCl. What will you get? You will get a salt. What happens? The sodium will combine with this chlorine and you will get the salt. Sodium chloride plus this hydrogen will be released. Okay. So sodium, if it combines with HCl for this activity, I didn't do that. Okay. But sodium, when it combines with HCl, you will get sodium chloride. This is the salt. This is the metal salt. Sodium is the metal. So the salt which is produced is sodium chloride plus hydrogen gas will be released. Then magnesium. Okay. Magnesium is a solid when it combines with H2SO4. Same way, HCl or H2SO4. If it is HCl, what will be the product? Magnesium chloride. Here it is H2SO4, so you will get magnesium sulfate. This will be in aqueous form. Aqueous form means what? You have already studied in the first chapter. Yes. With water it is mixed, no? That is called as aqueous form. Plus hydrogen gas will be released. The third one with calcium. Calcium also you can check. With calcium, if you are adding HCl, dilute HCl, you will be getting CaCl2. What is that? Calcium chloride. It will be in aqueous form plus hydrogen gas will be released. By seeing this, we can come to a conclusion that these are all electropositive. Right? We have studied the difference between metals and non-metals. The first point what we have studied is what do we mean by electropositive? What is electropositive? They will lose electrons. Right? So they will lose electrons. So automatically hydrogen gas will be released. The metals which are placed above, I said that they will have this kind of property. The metals which are placed below hydrogen in the activity series. Okay. They will not lose electrons. So they are what? Electronegative. No, this is electropositive and that is electronegative. What they will do? They will not lose electrons. So hydrogen is formed when metals react with okay, now I told only two this one HCl and H2SO4. You have studied 3 mineral acids, no? We have studied 3 mineral acids. What are those? HCl, hydrochloric acid. Why they are called as mineral acids? We used to get from organic acids. We used to get from plants, or animals. But this one you will get from minerals. So they are called as mineral acids. So this is the first part. What is that? With the help of activity, we came to know that this is the order. And the first point what we have studied, metals which are placed above hydrogen, no, they react with dilute HCl and dilute H2SO4 and they will give metal salt plus hydrogen. We have also seen 3 examples. Sodium, what happens? Sodium chloride. Whenever you write the equation, you write it in word also. Okay, word equation. Sodium chloride, magnesium plus sulfuric acid. This is hydrochloric acid, sulfuric acid. You will get magnesium sulfate plus hydrogen gas. Calcium plus hydrochloric acid gives calcium chloride plus hydrogen, electropositive. And I told these are above hydrogen and those who are below hydrogen, no, they will not lose electrons. So what happens? Will they give hydrogen? Metals placed below hydrogen in the activity series do not lose electrons. Okay, this is one part. The second part is, here hydrogen is produced, right? One more point, hydrogen is formed when metals react with HNO3. Is it correct? No. We have studied HCl and H2SO4 will give hydrogen. But this HNO3, now who is this HNO3? Good, nitric acid. Okay, this nitric acid is a strong oxidizing agent. So, hydrogen is not formed. Okay, hydrogen is not formed. Here hydrogen is formed, here hydrogen is formed, whether it is HCl or H2SO4. But here, if it is HNO3, what will happen? Hydrogen will not be formed. Okay? Why? The reason is, this is a strong oxidizing agent, not a normal one. It's a strong oxidizing agent. What will it do? It oxidizes the hydrogen produced. Hydrogen is produced here, no? Same thing here also hydrogen will be produced. But this HNO3 is a strong oxidizing agent. It will take that hydrogen and it will reduces it into an oxide of nitrogen. There are three forms. See, it can take that hydrogen and what happens? It will become nitric oxide or it will become nitrous oxide. First time you are studying anything. Nitric oxide NO. Nitrous oxide N2O. Nitrogen dioxide same like carbon dioxide NO2. Okay. So it can form its oxides. Which oxides? Oxides of nitrogen. So this is an important question. HCl and H2SO4 in the dilute form they react with metals and they give hydrogen gas, but an exception. What is that? HNO3 will not produce hydrogen. Okay. This is the fact. It will not produce, but there will be some exception. No. See in the class, if we ask to study all the questions, no, all the students will study and all. But again, one or two exceptions will be there. They will come and tell that, ma'am, yesterday power was not there, I went out, that happened, this happened, and some excuse will be there. Same like that here I told that all the metals, what will happen? They will not react. But see here, two people, magnesium and manganese. Okay, magnesium and manganese, what will they do? Even HNO3 is very strong oxidizing agent. Okay. Even though it's a strong oxidizing agent, what will happen? Magnesium and manganese, they will react with that and they will produce hydrogen. Good, no? So Mg plus HNO3. Mg is magnesium plus dilute HNO3. When it reacts, what will be the product? Magnesium nitrate. Okay, magnesium nitrate plus hydrogen. Okay, one example I have given. So this is what happens when metals react with what? Acids. Okay. So 5 points, will keep it in mind. First one, this formula you study. Second one, what happens when you do the activity. Third one, what happens when metals above hydrogen they are placed in react with dilute HCl and H2SO4 you have studied. Metals below hydrogen, what will happen? They will not lose electrons. So they will not produce hydrogen. Then the fourth point is hydrogen is not formed when it reacts with HNO3. Okay? Because the reason we have studied. And an exception for this is magnesium and manganese. They will react with dilute nitric acid and they will give their concerned salt plus hydrogen. This is the first time you are studying this word, I think. See, aqua. Have you heard of? Okay. This is also an important question. What is aqua? It is also called as royal water. See, ladies, they will be using gold. Okay. After some days, the luster will not be there. When you want to go for a function or something, your mother may give it for that goldsmith to get the luster back. Have you seen that? No. Okay. Next time you should check that. Okay, how it is getting that luster. So now to get that luster, what will he will do some magic. He will put inside some water. He will do like this. He will mix the ornaments and then he will brush it. It will get its luster. How is it happening? This is because of this magic water. Okay, royal water. It's called as royal water, also called as aqua regia. Aqua regia is a mixture of, see here, concentrated HCl and concentrated HNO3. It's very important. Don't write concentrated H2SO4. Here is no sulfuric acid. Concentrated HCl and concentrated HNO3. First point. Second point is the ratio also. Sometimes you will put the ratios opposite. See here, concentrated HCl 3 parts. See, for example, you are taking 200 ml of magic water. Which water? Royal water, or it is also called as aqua regia. In 250 ml, 3 parts means 150 plus 50, right? So this 150 will be HCl, this 50 will be HNO3. This you should keep it in mind. You should not put like 50 HCl and 150 HNO3. It's wrong. Okay, in this proportion. 3:1 ratio, concentrated HCl and concentrated HNO3 you should take. Then what happens now? See here, when it is mixed HCl plus HNO3, so this is called as aqua regia, a mixture. When you mix these two things, you will get nitroxyl chloride plus water plus nascent chlorine. Nascent means just born. When you are mixing like this, no, this chlorine gas will be formed. Okay, but it will not escape, it will remain there. So NaCl is nitroxyl chloride plus water plus chlorine will be there in the form of nitrogen. What happens when you put gold or platinum? For both we can use gold or platinum. When you put inside, what will happen? This chlorine which is formed now, this nascent chlorine will combine with this and you will get auric chloride or platinic chloride. Okay, if it is mixed with aurum, you will get auric chloride, platinic chloride, and you will get the luster back. Immediately he will take up. He will not put inside and leave it for 2-3 days. It will start dissolving. Okay. So it is used to clean metals which are placed in the bottom of the activity series. Okay. Especially gold and platinum. So this is very important, aqua regia. So this is all for today. What happens when metal reacts with acids? You should study all the 5 points. And this is also very interesting. What is aqua regia? The other name of aqua regia is royal water. What happens? Goldsmith, when he wants to get the luster back, he will put the metal, especially aurum or platinum, inside that. In which mixture? 3:1 ratio, concentrated. It is not dilute. Concentrated HCl, concentrated HNO3. When you mix these two things, you will get nitroxyl chloride plus water plus chlorine. And this will be very effective. This will act. Which will act? These two will not act. This chlorine which is present in the reaction, it will act with gold or platinum and you will get the luster back.